Since local coordinates were added to Minecraft, raycasting got significantly easier. But still, it is complicated to set up such a system. So objD brings the Raycast widget with it that you can use to deeply configure your own raycasting behavior with just a few arguments. But first, let's clear up the question, what is raycasting and why do I need it? To simplify it a bit, let's take a 2D surface first and place a player in it. The player obviously has some direction here, and we want to find out if this player looks at a certain object. Well, we can just gradually follow the facing direction and see if this line hits an object. And this is basically raycasting. You send out this ray into a specific direction and see if it hits something. This is useful if you want to implement a gun, for example, or what we do today, a drawing mechanic. So let's take a look at the widget then. Obviously you have to specify the entity or the player from which the ray should start here. And then you can give it a list of widgets that should execute when the ray hits something, by default a block. All the following arguments are optional, so you don't have to use them. For example, the max range here, or the step value that determines the accuracy. Then you also have the option to specify a block or a block tag that the ray should pass. By default this is block.r. Then the ray property is a bit special. It is executed on each step that the ray goes through. We'll take a look at this later. And then you can also specify an alternative scoreboard for counting that is used internally. So let's jump right into the code then. And here I specified a new file, Raycast. And this should have our child that we configured a second ago. So let's remove these few arguments here because that are the default arguments and see what it generates us. So here we have our raycast.mc function now, and we can see it executes another function internally that's located in this objD folder here, and it generated two functions, one ray1 function and one rayHit function. And this one at the end is just the ID of it. Like the group up here, the IDs are automatically generated. So you can have multiple raycasts in your project and this will still work and compatible. So our ray1 function is basically the core of everything. And this function is executed for each step. Like we saw in the animation, this ray increases. And for each time this increases, this function here is executed. And here you can also see the hit mechanism. And down here, the rayHit function is executed, where you actually have your things that you specified on hit. And then we also have a counter scoreboard that is increased for each step. And that is for this max value here. And then it goes one step further. So with this local coordinate here, it executes this ray function again. And it goes into the next step with the next position here. And this goes on and on until it hits something. So this objD ray hit is added and everything here happens in one tick. That means this is pretty much instant. So let's take a look at Minecraft. So here you can execute our function and the block that we look at is transformed into this white wool. And this also only works for 10 blocks. So if you look far away, this won't happen. And what's special about this is that everything happens dynamically. So if we remove this max property, for example, we can see this scoreboard is entirely gone here. You don't have it anymore and the performance is boosted because you have less commands here. So then let's take a look at the ray property again. There is a bit more to it because this here actually accepts a function. That means you have some inputs here and you return something. In this case, you always have to return a widget again. And you have also two inputs here. And one is a stop input and the other one is a hit input. We'll take a look at these properties here later. But for now, we can just return a particle with a particle type .flame, for example. And we also need a location, so location.here. And like I said before, this ray here is executed for each step that you define here. each block that it goes forwards, the particle is shown here. Let's also set this to 0.25 or something, and then we can take a look at this again. We can actually see this ray here because we have the particles, obviously. And we can also see the accuracy. This does exactly point to the direction that we are looking from our player's view, and we can hit much more with it. And here's the part where you can actually customize this very deeply, because you have these stop and hit functions here. So by default, this hit here is defined to work on a block. That means if you have any block in the way, this hit is called here. But in this ray here, we can now define custom hits. For example, if we hit another entity or if we hit a specific block. So let's return a for.off then, and then as well an if statement. And we want to check if an entity is near that is not of the type player. And then we just want to execute our hit method here. Oh, and what I forgot is we obviously have to set the distance here. So let's use a range up to 2 blocks. And now we can see this right here is added. So let's try and hit that cow over there. And yes, we made it. And the block is set in this cow right now. So this is the hit property here. You can just customize the hit thing, but we also have a stop. So let's say we want a barrier where this ray can't shoot through. And therefore we again specify a condition here, and we want the block.blue stained glass. Then we just simply want to stop it. So if at the current position is blue stained glass, we want to stop the ray here. So here I have this wall now. We can execute our function again, and you can see with the particles, the ray stops as it enters the blue glass. And on the other side, it works again. So this would be the Raycast widget. If you have questions, put them in the comments below. And also head over to stevatus.com/objD to get detailed documentation on raycasting and all the other widgets.